Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence from you guys, the quality of my video and as well as audio. Is it perfect or not? If it is perfect, just write the perfect over the comment box and then we'll move ahead. Just write the perfect over the comment box. Hello SS series. Just I wanted to get the feedback of my quality of video as well as audio. Is it perfect or not? Is it perfect or not? Good afternoon, Vaishnavi. Perfect audio and video. Okay. Now, let me recall what we have studied in the last class. In last class, basically, I started the concept of linear algebra. At very starting, we talked about the comparison between the determinant as well as the matrix, because most of the time we used to have difficulty and we used to understand the matrix as well as the determinant is very same. No, we talked about that in great detail. The determinant used to have only one information, whereas in case of matrix, it used to have n number of informations. Thereafter, we talked little a bit about the varieties of the matrix we have. Among them, the first and very important matrix which we discussed was a square matrix. The name itself is self-explanatory, a matrix which will have the square in structure, or you can say the number of rows and columns are same. Why the square matrix is so important? Because few of the very important concepts we are going to deal with the square matrix alone. Like once we discuss about the inverse of a certain matrix, that matrix has to be a square matrix. Similarly, once we talk about the concept of eigenvalues as well as eigenvectors of a certain matrix, the matrix has to be a square matrix. Thereafter, we moved forward and we talked about singular and non-singular matrix. The matrix is said to be a singular if its determinants becomes 0, and similarly it becomes a non-singular if its determinants it's not equals to 0. And similarly, we also connected the invertibility with the singularity. If a matrix is found to be a singular matrix, it won't be invertible, or we can call it non-invertible. That we have seen in the last class. And similarly, if a matrix is a non-singular matrix, by default the matrix would be a invertible matrix. Thereafter, we talked about skew-symmetric matrix as well as symmetric matrix. Even we saw a square matrix can be changed to a sum of skew-symmetric and symmetric matrix at any moment of time. We need not to worry about it. All of these square matrix can be written in terms of the addition of symmetric as well as skew-symmetric matrix. Is that part clear? And similarly, we went ahead and we talked about the orthogonal matrix, a special kind of matrix. When the A gets multiplied with the A transpose, the result becomes identity matrix. Anyways, that happens when the A transpose is equals to of A inverse. That we talked in the great detail. Even we talked about the concept of rank. In concept of rank, we concluded the rank of any matrix is equals to of number of linearly independent number of columns as well as rows. At very initial phase, the row for the column and the rank for the column as well as rank for the row was the two different or two distinct concept. But in last class we could figure it out. No, the value would always be same. So rather calling it rank for column or the rank for row, always I would simply be calling it rank itself. Even in last class, we also discussed about the concept of eigenvalues and eigenvectors, and definitely I feel now you would be able to visualize the concept of eigenvalues as well as eigenvectors, because graphically you could correlate. Now in today's lecture, we are just going to focus over the numerical angle of linear algebra, and around 8 number of previous year questions I have brought for you guys, and end of the day, once you will be able to connect your concept with this 8 number of problems, you would be almost able to manage all of the important topic within the linear algebra. So if you want, I can show you which are the questions I have been taking. Just a minute. This 8 number of questions I am going to take, and mostly 3 or 4 number of questions have come from the eigenvalues and eigenvectors itself, and I know you guys find yourself difficult to deal those sort of problem. Usually most of you are very acquainted. If a square matrix is given, you guys might be able to calculate its eigenvalue and corresponding eigenvector. If the conceptual problem comes from the concept of eigenvalues and eigenvectors which are repeatedly coming, you will find yourself trapped. But anyways, those questions I am going to smash today itself, and really end of the day you will enjoy. Similarly, we are also going to discuss little a bit about the Cayley-Hamilton. Even the one question have already been taken from the Cayley-Hamilton. Like, let me go down. Yes, one question is already been taken from the Cayley-Hamilton, and once the Cayley-Hamilton is done, we'll go into the different solutions of a linear form of an equation, maybe a homogeneous form as well as inhomogeneous form. Anyways, the problem do come from this topic also. This topic also. Is that part clear? Anyways, let me go to my working board and let me take a question. Let me take a question. In yesterday's class, we were talking about the process how to get the eigenvalues and eigenvectors for a certain square matrix. In yesterday's class, the matrix which I have chosen was in order of 2 cross 2, but deliberately I am taking a next label of question which has order of 3 cross 3. So write it down. My question goes like this. My question goes like this. Find the eigen, few of the teacher says it eigen and few of the teacher says it eigen. Any of them it's correct. Find the eigenvalue and eigenvector. Vector for matrix A. And let's take the matrix A has been brought in the picture, where the matrix A is being defined as a matrix which is square in nature, has 3 cross 3 in order, 2 0 0 0 4 5 0 4 3. This is what my matrix is. Is that part clear? There's so many concepts we are going to learn. That's a different story together. Definitely the process itself is a bit lengthier. So you are also had to learn the process how we will get the eigenvalues as well as eigenvectors if a matrix is in order of 3 cross 3. But is still so many conceptual details we are learning while I'll go till the calculation of eigenvalues as well as eigenvectors. So may I know how the eigenvalues are being calculated? Let me take the first point. How the eigenvalues are being calculated? Eigenvalues are being calculated. We have seen in the last class, we used to form a matrix A minus of lambda I, and I need to take a determinant of it and compare with 0, which will make a equation, It's called characteristic equation. So in future, you need not to worry about it. This equation have got a standard name and which is called a characteristic equation. So whenever I say the characteristic equation of any square matrix, by default it's gonna be mod of A minus of lambda I, which is equals to 0, That's the first thing. Now may I know what would be the degree of this characteristic equation? That is the next point to be noted, because few of the conceptual problem is being asked from here. May I know what would be the degree of this characteristic equation? I want the input in the result. Sir, in rank problem, I cannot find the relationship between, no issue. We'll try to correlate each and everything, but at last. May I know what would be the degree of this characteristic equation? 3. See, why the degree of the characteristic equation is 3? Once you feed A minus of lambda I, what will happen? It will become 2 minus of lambda, it will become 4 minus of lambda, it will become 3 minus of lambda, and once you will take a mod of it and once you will compare with 0, the degree of the characteristic equation would be the number of or the order of the square matrix itself. So from here onwards, at least you can recall or remember one thing. If we talk about the degree of the characteristic equation, it would always be equals to the order of your square matrix. Like here order is n cross n, that means 3 cross 3. So the degree of the characteristic equation is going to be 3. And similarly, in the last class, we have calculated one problem thoroughly. Even if you'll go in that point and you'll try to calculate the degree of the characteristic equation, you'll get to know that's nothing but 2. Nothing but 2. Is the part clear? So straight away what we had to do? A minus of lambda, so it becomes 2 minus of lambda, the 0 will remain 0, 0 will remain 0, 0 will remain 0, 4 become 4 minus of lambda, the 5 will remain as it is, 0, 4, 3 minus of lambda. I need to take the determinant of it and has to get compared with 0. Has to get compared with 0. Is that part clear? So end of the day, you will be land up with a function of lambda towards the left hand side, and which would get compared with 0. Which would get compared with 0. And if we talk about the degree of this polynomial f of lambda, the degree would be is equals to 3. If you want, you can write somewhere an important point. The degree of the characteristic equation is equals to order of the square matrix. Degree of the characteristic equation is equals to of order of the square matrix. Order of the square matrix. Is that part clear? Already I have calculated the values of lambda. May I know how many number of lambdas you'll have? See, each and everything is related, no? In future, few of the good amount of questions, once you'll go through on that, no? Definitely these basic concepts are going into the clarity picture again and again. So you had to have very clarity in it. So if the degree of this polynomial is 3, which is getting compared with 0, so how many value of lambdas you will be having, which will satisfy this equation? 3. What does it mean of it? In future, if you have 2 cross 2 matrix and for that you wanted to get its eigenvalue, how many number of eigenvalues you will have? 2. Similarly, if it is a matrix of 3 cross 3, how many number of eigenvalues you will have? 3. Similarly, if it is a matrix of 4 cross 4, how many number of eigenvalues you will find? 4. Similarly, if it is a matrix with an order of n cross n, how many number of eigenvalues you will find? N number of eigenvalues you will find. How? Because the degree is going to be decided by the order, and the degree of this polynomial is same as the order of the matrix, and hence in future you should have a clear-cut idea about it. I am not going into the great detail of f of lambda is equals to 0. I have just calculated and brought the eigenvalues which we are getting out of this. It's a -1, then 2, then 8, then 8. So you guys had to just calculate the roots of this cubic polynomial, and thereafter you will get the result out of it. Now, in yesterday's class, my basic focus was on eigenvector, because till eigenvalues I find the most of the students are more than comfortable, but once they go with the eigenvector, they find themselves difficult. What I will do from here onwards, I will focus over the calculation of eigenvectors. And eigenvectors would be calculated in correspond with the eigenvalues. So how many number of eigenvalues you have got it? 3 number of eigenvalues. So let me take the reference of the first eigenvalue. I may call it lambda 1, which is equals to of -1. Now, what we will be doing from here onwards? See, lambda is equals to of -1. Yes, -1 would be fed over here, or simply you can feed over here. So may I know what would be the new matrix? The new matrix is gonna be 2 minus of -1, that would become 3, 3, 0, 0, 3, 0, 0. And similarly, here it becomes 0, 4 minus of -1, that will become 5 over here. And here it would become 5 over here, and similarly here it becomes 0, 4 and 4 again, and here the eigenvector would come in picture. How many number of datas it would have? 3 datas it would have, and it would get compared with a null matrix again, which would be a column matrix. So before going into the great detail, just I wanted to ask one thing. The 3 number of equations would be retrieved by comparing the left hand side as well as right hand side. How many equations are the effective equations? Although the 3 equations you are getting out of this, how many equations are the effective equations? I want the numbers over the comment box. How many equations are the effective equations? Tell me. How many equations are the effective equations? Or linearly independent number of equations are how many? I want the comment over the comment box. Tell me. 2 number of equation, 2, obviously 2. How so? See, the row number 2 or the equation number 2 and equation number 3 are linearly dependent. How? If the equation number 2 is divided with 5 and multiplied with 4. If we divide with 5, what it will become? It will become 1 and 1. And if it gets multiplied with 4, it will become 4 and 4. That means the equation number 2 and equation number 3 is linearly dependent equation. So as far as the linearly independent equations are concerned, the two equations you have got it. If you want, we can write over here itself, or let me go down. Yes. So the equations are 3 times of x1 plus of 0 times of x2 plus of 0 times of x3 is equals to 0, and similarly 0 times of x1, either you can choose the second equation, either you can choose the third equation. 5 times of x2 plus of 5 times of x3. If you want, you can simplify this problem here itself. 3 can be taken common in the first equation, which would go towards the denominator at the right hand side. So this 3 can be just omitted. Is a yes or not? Obviously yes. And similarly, the 5 can be taken common from the second equation. So this 5 and this 5 goes out. May I know how many solutions you will have? Will you have the unique solution of x1, x2 or x3, or you will have an infinitely many solution of x1, x2 and x3? I want your concurrence input over the comment box. How many number of solutions you will have? Will you have a unique solution, or will you have an infinitely many solution? I want the reply from you guys over the comment box. Infinitely many solution. How, sir? How could you figure it out? See, number of effective equations or number of linearly independent equations are how many? 2. And the number of unknowns are how many? 3. Whenever if you want to write, you can write it out. Whenever the number of effective equations are lesser than the number of unknowns. Whenever number of effective equations or linearly independent equations are lesser than the number of unknowns, you will have infinitely many solution. Now people still will find themselves very difficult. How did you say, sir? See, for the time being, at very starting, I can feed x1 as 1 maybe, and x1 is equals to 1 in first equation as well as second equation. If the x1 is kept as a 1, it will become 1 and it will become 0. Now you have an equation which have got the 2 number of unknown terms as well as 2 number of equations. You will get the value of x2 and x3. But what will happen? You can change the value of x1. You can keep 1, you can keep 2, you can keep 3, you can keep 4. So in all of the varieties of x, you will be getting the different values of x2 and x3. So the number of solutions are going to be infinitely large. Is that part clear? Now recall the same concept. Why the infinite number of solutions we have got as an eigenvector? I want the reply from you guys in comment box. Why you have got a situation when we have infinitely many number of solution? I repeat it again. Why the equation which has been brought it out by comparing the left hand side as well as right hand side always will have infinitely many solution. Can you tell me the basic or reasoning or the concept behind the infinitely many solution? Can you tell me over the comment box? Try to understand. In future, we are going to discuss, probably in today's class itself, we are going to discuss about the concept of linear homogeneous equation. How used to be the linear homogeneous equation? It used to be sort of bx is equals to of 0. Yes. Let's take the B is a matrix of n cross n, X is a column matrix of n cross 1, and it's a null matrix again with the order of n cross 1. Now try to understand. If you guys are a little bit idea about the infinitely many solution, which case it is? It's a linear homogeneous case. Linear homogeneous case. Homogeneous case. When we used to have infinitely many solution. Infinitely many solution. Infinitely many solution. Everything is connected. No, even the rank will also come into the picture. Infinitely many solution. It takes place when the rank of B matrix, rank of B matrix is lesser than the number of unknowns, and here it is n. Here it is n. Here it is n. Is that part clear? Here it is n. So again, what I am saying, the concept of eigenvector I am connecting with linear homogeneous equation. Linear homogeneous equation. Now one of the great thing. See, if rank of B is lesser than n, what will happen? The determinant of B would be 0. Just try to understand what I am saying. If rank of B is lesser than n, we have already talked this thing in great detail in case of rank. If rank of B is not n, that means once we talk about the determinant of B, it becomes 0. It becomes 0, that we have seen. Like if you have a 3 cross 3 matrix, if the determinant is gonna be 0, it won't be 3 in rank. Either you had to start from 2 or it have be 1. Similarly, same case happening over here. So if you have an infinitely many solution, the rank of B has to be lesser than n, and if the rank of B is lesser than n, the determinant of that matrix has to be 0. And one of the very important point, may I know what would be the determinant of this matrix? Yeah, the basic behind this matrix itself is a mod of A minus of lambda I is equals to 0. That means for its possible lambda, its determinant will always be 0. And if the determinant of this square matrix is 0, definitely this linear homogeneous equation will have infinitely many solution. And hence, if x1, x2 and x3 are having an infinitely many solution, may I know what is x1, x2, x3 together? It's a column matrix, and which is being referred as the what? Eigenvector, and hence the eigenvector would have infinitely many solution. Infinitely many solution. Could you figure it out? Why we used to have always a case of an infinitely many solution? Whenever you deal with the eigenvector, you will be land up with a situation where the number of favorable or number of effective equations would always be lesser than the number of unknowns. Like here, 3 number of unknowns you have, and how many number of effective equations you have got it? Only 2. Could you figure it out? Why the eigenvectors are not unique? Why the eigenvector is not unique? Because the eigenvector is the solution of a linear homogeneous equation where the equation may be B or maybe matrix B has the determinant is equals to 0, and if the determinant is 0, the rank could not be 3. If the rank could not be 3, it will have infinitely many solution. If this part is clear, just write it clear over the comment box, otherwise I'll repeat it again and we'll go forward. Anyways, end of the day, all of the important properties which is inherited by eigenvalues as well as eigenvectors, we are going to write point to point. Is the part clear or not? Just tell me clear. Tell me, do it fast, we'll move forward. Only one clear, probably students are not able to connect what I wanted to say, but no issue. In today's class, we are going to discuss about the linear homogeneous equation. Definitely there I would be discussing about that also. Is that part clear? So let me go down. So now how to deal with this sort of problem? Now the x1, x2 and x3 will not have a unique value, but yes, they will follow a certain relationship. How do we get them? We used to calculate this using the method of cross multiplication. X1, and here what will happen? It would have the determinant of the rest of the terms, which includes 0, 0, 1 and 0, 0, 0 and 1. 0, sorry, it's a 1 and 1. No, sorry, it's a 1 and 1. 1 and 1. Keep in mind here the minus sign comes. Many of the student gets confused over here itself. Now if you are standing over here, you have to leave this column. You will start with the term. The x1 is 1, then here it's gonna be 0, then it's gonna be 0, and then it's gonna be 1. See, Dilip, you need not to worry about anything because I have designed 8 number of problems and we are going to discuss about this short trick for the calculation of the eigenvectors. You need not to worry about it. See, similarly, it goes to x3. Here the x3 comes positive. Here it's a 1, 0, 0, 1. 1, 0, 0, 1. And it would get compared with k. Is that part clear? So now if we talk about the determinant of it, so 1, 0, 0, 0. So x1 is equals to of 0 into k, that's a simply 0. Similarly, if we talk about the x2, it's gonna be minus of k. How? Minus of x2 divided by f1, 1 goes towards right hand side, 1 into k, that's a k. Minus of x2 is equals to k, so the value of x2 is equals to of minus of k. And similarly, x3 is equals to of k. So if we talk about the eigenvector, it's simply gonna be 0, minus 1 and 1. And keep in mind what it is. This eigenvector is true only for its corresponding eigenvalue. May I know which eigenvalue it was? For the lambda 1 is equals to of minus 1. Lambda 1 is equals to of minus 1. Minus 1. Is that part clear? If you want, you can recall one more important thing. Conceptually, matrix to matrix multiplication, which was matrix to matrix multiplication, AX is simply equals to of constant to matrix multiplication, and it's happening for sure. You can have that data. May I know what's the x over here? The x is nothing but k. You can take this as a constant in future. 0, minus 1 and 1. May I know what's the matrix A? Matrix A can also be written over here. May I know what is the data over here? Let me see over here. The data was 2, 0, 2, 0, 0, 0, 4, 5, 0, 4, 3. Let me multiply this. The k is common. Let it be outside. And once we start multiplying them, so it becomes 2 into 0, that's a 0, 0, 0, 0. It's just simply equals to of 0. Similarly, here it's a 0. Here 4 minus of 1, that becomes minus of 4 plus of 5, that's a 1. And you can get the value out of this. And similarly 0, 0, minus 4, and similarly here it becomes minus 1. Could you figure it out what it is? It was a and x, and may I know what it is? If the minus sign is taken out from here, it would become simply minus 1 k times of 0, minus 1 and plus 1. May I know what it is? It's again x, and what it is? It's a lambda. So put together, what's the result out of this? Although a very complex matrix got multiplied with the vector, but end of the day, the result was just a expansion or squeezeness of the same vector. If you want, graphically you can understand this. So let me take a graph over here. How it would be. Yes, let's take it's a 2D plane. Where this was kept. Now see, in 2D plane I cannot place those values. It has to be placed over the 3D plane. It would be 0, minus 1 and plus 1. It would be somewhere here. And now once it gets transformed with A, what's the result you get? You get the result is same as the squeezeness or the compression of the given vector. Is that part clear to all of us? Now the homework goes to you guys. You also had to carry out the value of eigenvectors for the rest of the values of lambdas, which includes 2 as well as 8. So you had to carry out the calculation of the eigenvector for the 2 as well as 8. Now the problem is never going to come from 3 cross 3 matrix. They are not going to ask the eigenvector for a square matrix which is an order of 3 cross 3. No, it's not going to be asked. Why? Because the calculation is too difficult. Not only here, even the calculation of lambda is also very difficult. Why? Because you had to deal with a cubic equation, and getting the root of the cubic equation is not that easy task. So the problem will not be straight away asked from a 3 cross 3 matrix. So most of the time they ask a problem from a 2 cross 2 matrix, and even the problems are formed from the 3 cross 3 matrix. They have been formed in a certain different way, which can be easily smashed using the method of shortcut. So what are the conclusions we have drawn out of this? And now we are going to write those as the conclusions. And the important points regarding the eigenvalues as well as eigenvectors, and thereafter straight away we'll jump into the few number of problems. The first, the number of eigenvalues you'll have, that solely depends on the order of the matrix. If the order is 3 cross 3, the number of eigenvalues would be 3. The next question comes, sir, how would be the nature of the eigenvalues? Would it be always real? Would it be always integer? Or can it be a complex form? Yes, all sort of possibilities are there. That means the eigenvalues can be real, imaginary, pure imaginary, complex, and even zero. So anyways, few of the important fact. Now we need to list it down, and you guys had to have the fair idea about all of the important points, because the problems are keep coming from these properties. So write it down. The important properties. And very important properties we are going to discuss over here. Let me take the first important property. Yes. If you have a matrix with the order of n cross n, how many number of lambdas you will have? N number of lambdas you will have, which starts from lambda 1, lambda 2, and goes till lambda n. That's the first important thing. Similarly, lambdas could be pure real, imaginary, pure imaginary you can write, pure imaginary, even they can be complex, and at worst situation it could be even zero. So you guys need not to afraid about this. Like, you have got a problem, and while calculation you could land up with a situation where the value of lambda is got somewhere 2 plus minus iota. You need not to get confused in it. Yes, it could be a possible values. Not only that, even the lambdas can be distinct. That means you have the different values of the lambda, and even they can be repetitive. So you need not to get worried on that. You can have any sort of situation. Is that part clear? Till this point, probably each and everything must be clear to all of us. Now, one of the very important fact, and I know around 7 to 8 number of times the problem has come from this particular zone, and you guys have surrendered yourself. So let me go ahead. Now, let me recall the basic concept behind the eigenvector. The basic concept behind the eigenvector was the matrix to matrix multiplication was equals to of constant to matrix multiplication. Now, what I am going to do, now I am changing my matrix. Initially, we had a matrix A, and for matrix A, we have got an eigenvector x corresponding to the eigenvalue lambda. But But now if you have a certain case, you have got a matrix A, you know its eigenvalue, you know its eigenvector, but now that matrix A has been made to the A square, what would be the change over the lambda? What would be the change over the x? Similarly, now if A has been made to A cube, what would be the change over lambda? What would be the change over the x? And at last, or at worst, you can say, if A has been raised to the power of n, what would be the change over the x as well as lambda? That we are going to talk on. Is that part clear? So what I am going to do, multiplying matrix A both side towards the left hand side, both side. If the left hand side, the A got multiplied, the A into A becomes A square of x. And similarly, A into lambda of x, lambda is a constant, keep in mind. Commutative property is not valid for matrix multiplication. If A is getting multiplied over here, the A has to get multiplied over here. So can I shift lambda over here? Yes or no? Put it over the comment box. If the A is getting multiplied over here, can I shift lambda over here? Yes or no? Put it over the comment box. Yes. Why? Because lambda is not a matrix, it's a constant. Lambda can be put it towards the left hand side. So may I know what's going to be the result out of this? It's just simply going to be lambda of Ax. Yes. Now, may I know what's the Ax? Already Ax is known to be lambda x. So again, the Ax would be replaced with the lambda x, and lambda will become multiplied and they will become lambda square of x. Is that part clear? And one of the great thing regarding this, A square is a matrix which is getting multiplied with another matrix, but end of the day, it's the same like a constant multiplication with a matrix. Again, it is making the concept of eigenvector. What the eigenvector states? The eigenvector states you have got a certain possibility where the matrix to matrix multiplication helps for the constant to matrix multiplication. That means let me recall, in case of Ax lambda x, let's take lambda was lambda 1. And corresponding to the lambda 1, let's take the eigenvector was x. May I know if matrix has been changed to A square, what would be the change over the lambda? See, the lambda have become lambda square. Initially the lambda was lambda 1. You can just rub it out. The lambda was lambda, but now it will become lambda square. But most important thing, the eigenvector is not going to change. That's the very important point. Everybody should have clear-cut thought in your mind. And similarly, if instead the A square, if we deal with the A cube, may I know what would be the situation over there? If we talk about A cube is getting multiplied with x. May I know what would be the situation over here? The A cube x, again it would become A square into A of x. Result would be somewhere lambda to the power of 3 into of x. So may I know what would be the change over here? The lambda would become lambda cube, and similarly the x would become, or x would remain x. Is that part clear what I am saying? X would remain x. That's a very important factor. Everybody should notice about it. So you can say if you have got a matrix A, let's take its order is in order of n cross n, and its eigenvalues of lambda 1, lambda 2, lambda n. Now what you did? You raised the power of that matrix. That means you have made a new matrix. Let's take it's a to the power of m. Again, the result would be a n cross n matrix. May I know what would be the result, or what would be the impact over the eigenvalues? The each and individual eigenvalues would be raised to the m. And one of the best thing about it, corresponding to the lambda 1, let's take you have eigenvector x1, corresponding to the lambda 2, you had eigenvector x2, corresponding to the lambda n, you had eigenvector xn. May I know what would be the eigenvector corresponding to the lambda 1 to the power of m? It says still x1. And similarly corresponding to the lambda to the power of m, it's again x2 and it's again xn. I know you guys might be finding this complete concept a little bit tougher, but once I'll apply over the best of the best problem which have appeared in the GATE examination, you are going to appreciate this. You are going to appreciate this. What does it mean of it? That means if the power of a square matrix is keep increasing, the values of lambda would also increase with the same fashion. But the corresponding eigenvectors is not going to change at all. The corresponding eigenvectors are not going to change at all. You can see from here. See here in case of this, there was no change, and similarly in case of this, there was no change. Is the part clear? So you can just visualize in this way. You can just visualize in this way. You can just visualize in this way, and thereafter we'll move forward. Till this point each and everything is clear. You just write clear, and thereafter we'll move forward with few more number of important properties which would be processed by eigenvalues as well as eigenvectors. Eigenvalues as well as eigenvectors. So let me go down, or I may go into the next page. And let's take the next important point. Eigenvectors are non-unique vectors or non-unique column matrix. So write down this also. Eigenvectors are, you can see, you have seen that, no? Eigenvectors are non-unique. Even you will have infinite many number of situations. Non-unique, always it will be a column matrix. Non-unique column matrix. That is also okay. Now let me go ahead with the next. One of the important feature you will be seeing, and this feature is very important once we deal with the numerical problems based on the eigenvalues especially. Like you have got a matrix A which is an order of n cross n. Number of eigenvalues are like lambda 1, lambda 2 till lambda n. You will get to know the additions between all of the eigenvalues. It starts from lambda 1 and goes till lambda n would be equals to of trace of the matrix A. May I know what is the trace of the matrix A? The trace is nothing but the sum of its principal diagonal elements. And similarly, the multiplication between all of the eigenvalues would be simply equals to of determinant of the matrix A. Write down the trace is nothing but sum of all principal diagonal elements. Like if you want, you can have an example. Like if you have got a square matrix 2, 3, 4 and 1. So if we talk about the trace of this matrix, we just had to focus over its principal diagonal elements which are 2 and 1. So the trace of this matrix would simply be 3. So the addition of all eigenvalues is very same as the trace of the square matrix for which the lambdas has been calculated. Is the part clear? So just a minute. Is the part clear? Till this point, I feel you guys are able to correlate the concepts very well. The last important point, as far as the important points, the list of the important points of the eigenvalues and eigenvectors are concerned, the huge number of properties you have got it. I am just going to list down only the important properties. Is that part clear? Now the last and never the least important property, you can just write down. Eigenvalues and eigenvectors are correspondent to each other. eigenvalues and eigenvectors are corresponding to each other. Eigenvectors are corresponding to each other, and end of the day, see, if any of the lambda becomes 0, in that case the determinant of a matrix A becomes 0, and if the determinant of any certain matrix A becomes 0, that matrix becomes a singular matrix. So one of the important fact you can get out of this, for a singular matrix, singular matrix means the matrix having a determinant is equals to 0. For a singular matrix, at least one lambda is 0. At least one lambda is 0. Yes. At least one lambda is 0. Is this quite clear? So I would just suggest keep this thing in your mind, and once we'll connect this properties with your core problem, definitely you guys are going to appreciate the concept in individual fashion. Not only that, even in the first question, when we took a problem of a 3 cross 3, the same property is getting followed. May I know what's going to be the trace of the matrix A? The trace is going to be 2 plus 4 plus 3. That's going to be 2 plus 4, that's a 6, plus 3, that's a 9. That means in future the additions of 3 lambdas has to be 9, and you can see very well, yes, it is 9. 8 plus 2, that's a 10, minus of 1, again it's a 9. That's the first property which we have already correlated. And even once we'll take a determinant of it, now the determinant has to be the multiplication between their eigenvalues, minus 1, 2 as well as 8. So here you can write, you can easily see trace of the matrix is simply going to be 2 plus 4 plus 3, that's going to be 9, and which is very same as the addition of lambdas, which is minus 1 plus of 2 plus of 8, again which is 9. And keep in mind, it's always true. You need not to worry about it, it's always true. Is that part clear? Similarly, if you go ahead with the next concept, and if we talk about its determinant, what would be the determinant? Determinant of this matrix is simply going to be 2 into 4 into 3. Yes? If we talk about the determinant of this matrix, is simply going to be 2, just a minute, get it the value of it, and similarly, end of the day, you will be landing up with the minus 1, 2 and 8. And here it's going to be minus 16. And once you'll calculate the determinant of the matrix A, you'll land up with the same value. Is it quite clear? So now, let me go ahead with few number of problems, and you guys have to give a proper answer for the each and individual problems. So let me start with the first question. The problem have come in GATE Electronics year of 2016. The problem was framed by ISC Bangalore. The problem states the value of x for which the matrix A is equals to of 3, 2, 4, 9, 7, 13, minus 6, minus 4, minus 9 plus x has 0 as an eigenvalue is. Anyways, the answer is clearly marked over here, but I would suggest to each and everyone, try by yourself and try to get it the answer within maybe 30 to 40 seconds. So I'm just waiting for the 30 to 40 seconds and just waiting what's going to be the reply from you guys. Tell me what would be the best most answer. What would be the best most answer? What would be the best most answer? What would be the best most answer? I want the reply over the comment box. Nobody should read the answer, and just try by yourself and try to give the answer for this. Tell me what's going to be the best most answer. And what would be you guys' approach? The approach should also be very clear, because this problem can also be solved using a very shortcut method. Okay, the first input have come, determinant is equals to 0. What else? See, if you have a matrix, with an order of 3 cross 3. 3 cross 3. How many number of eigenvalues you will have? The 3 number of eigenvalues you will have. You have already seen this thing in its properties. In its properties, it has been clearly given has 0 as an eigenvalue. If any of the eigenvalue is 0, so the multiplication between the eigenvalues becomes 0, and as per the property, it is also equals to the determinant of the matrix. Determinant of the matrix. What's the result you can get out of this? That means the matrix A is a type of singular matrix. Singular matrix. Now here the number of student will get bifurcated in the two part. The one jump or the one chunk of the student, they will straight away go into the determinant of this matrix and will compare with the 0 and try to get the value of x. That would be the first chunk of the student. Even I can distribute the two different methods from here. Method number 1, which will take huge amount of time, and method number 2, which is not at all taking time. So in first method, what the students are supposed to do, they will take the determinant of 3, 2, 4, 9, 7, 13, minus 6, minus 4, minus 9 plus of x. They will take a determinant of it and they will compare with 0. And the smart student, what they are going to do? See, if the determinant of a 3 cross 3 matrix is 0, that means its rank cannot be 3. If the rank of the matrix cannot be 3, that means the number of linearly independent either rows or columns cannot be 3. That means out of 3 number of rows, at least 1 row is a dependent row. I repeat what I am saying. If the determinant is found to be 0 for a given square matrix, that means the rank of this given square matrix cannot be 3. That means number of linearly independent rows or columns cannot be 3. Although you are seeing the 3 number of rows, but out of 3 number of rows, at least 1 row has been brought by just the linear dependency over last 2. And now you can see very well R1 and R2, they are precisely linearly dependent. See how the R1, 3 became minus 6, 2 became minus 4. That means simply R2 has been found by just multiplying minus 2 times of R1. Now, if even the minus 9 plus x follows the same relationship with 4, in that case, the R1 and R3 will become linearly dependent, and definitely your requirement is satisfied. So, what you will do, you will just focus over this. This is linearly dependent, minus 2 got multiplied. So what you do, you multiply minus 2 with 4 and compare with the element on R3. It's a minus 9 plus of x. So here it becomes minus 9 plus of x minus of 8. X is simply equals to of minus 8 plus of 9. The result is simply going to be 1. Even by seeing also, you can easily get the answer of this. But once you'll go through this process, you had to get the complete determinant, and end of the day, probably the wrong answer you can calculate. Could you understand how the method 2 was so important? See, determinant of A is equals to 0 indicates the rank of the matrix A would be lesser than 3. If rank of the matrix A is lesser than 3, that means the number of linearly independent rows would be 2 or lesser than 2. They can't be 3. That means out of 3 number of rows, at least 1 row has to be dependent. And just try to figure it out where it is. Just by seeing itself, you got the answer. And see, the problem was framed in that way alone. Because the person who have framed this problem, he just wanted you to drag into a longer process, and he also wants to filter it out, the student who have prepared superbly and the students who are just have a little bit idea about the mathematics. Is that part clear? If it is clear, just write clear. We'll move ahead with the next question. Is the part clear? Tell me till this point if you guys are having any problem, you can just ask. You can just ask. Now let me go ahead with the next question. Let me go ahead with the next question. And I know this is the problem many of the students are going to leave with. Can you tell me what's going to be the exact answer for this particular question? What would be the exact answer for this particular question? Obviously, the answer has been written as a -6, but you guys had to solve by your own. The problem have come in GATE instrumentation year of 2016. The problem was framed by ISC Bangalore. And once this problem is done, I will take my own design problem and I will show you how effectively the concept of eigenvalues and eigenvectors can be used for formation of a good question. Consider the matrix 2, 1, 1, 2, 3, 4, -1, -2, -2. It's a problem of a 3 cross 3 matrix whose eigenvalues are 1, -1, 3. Then the trace of a cube minus of 3a square would be. Tell me, what would be the answer out of this? What would be the answer out of this? I am just giving the answer, just giving the time for 1 minute, and you guys had to reply. What would be the best most answer for this? What would be the best most answer for this? So until and unless you do not know the new eigenvalues for a new matrix a cube minus of 3a square taking the reference of the eigenvalues of a, you will not be able to calculate the trace, as the trace of any kind of matrix is very same, is equals to of the addition of its eigenvalues. So focus over the eigenvalues of a cube minus of 3a square. A cube minus of 3a square, and I know many of the students will get stuck over here itself. Is that part clear? Same concept I am going to use. In case of eigenvector, we used to have a matrix which gets multiplied with a eigenvector and results as the constant to vector multiplication. We have seen one more thing. A to the power of nx is equals to of lambda to the power of nx. Yes or no? Obviously yes, sir. There is no problem as such. So here we can see one more thing. That means what are the terms we are having there? A square x would become lambda square x, and similarly a cube x would become lambda cube x. Yes or no? Obviously yes, sir. So what we are going to do, each and everyone should have the focus over the next process which we are going to carry out. See, let me take this as equation number 2 and let me take this as equation number 1. And I am just manufacturing this complete structure in the form of this. Is that part clear? Then what will happen? I am just taking equation 2 is getting subtracted with the equation 1 by just multiplying 3. So here at left hand side it becomes a cube of x minus of 3 times of a square x. At right hand side it becomes lambda cube of x minus of 2 times of lambda square of x. Now let me do one thing. X can be taken common, so here it becomes a cube minus of 3 times of a square is equals to of lambda cube minus of 2 lambda square. Now just compare with this two equation. Let's call it it's the equation number A, and let's call it it's the equation number B. See, you had the matrix A, and for matrix A you had the eigenvalue lambda, and corresponding to the eigenvalue lambda you had the eigenvector as x. But now you have matrix B, a cube minus of 3a square would be another kind of matrix. Let's call it B. Matrix B. For matrix B you have its corresponding eigenvalue as lambda cube minus of 2 lambda square, but you have the same eigenvector. That means if I compare the previous eigenvalues, the eigenvalues have got to change to lambda cube minus of 2 lambda square, whereas the eigenvectors are precisely same. Still, I understand many of the students would be finding this concept very difficult. Sir, how the lambda is changing, how the x is not changing? I am going to tell you by taking an example, because so far the problem based on those concepts has not been covered. So may I know what would be the new lambdas? Let's take the initial lambdas were lambda 1, lambda 2 and lambda 3. So now the lambda 1 dash, it's a new lambda, lambda 2 dash, it's a new lambda, and the third lambda is lambda 3 dash. How they would be? You'll just feed the 1 over here, you'll feed 1 over here. May I know what's going to be the result out of this? Here it is going to be 1 to the power of 3, that's a 1, minus of 2, that would be simply equals to of minus 1. That would be simply equals to of minus 1. Similarly, now you will feed minus 1. So minus 1 to the power of 3, that will become minus 1. Minus 1 and minus 2, that will become minus 3. Minus 3. Minus 3. End of the day, you have to feed 3 over here. End of the day, you have to feed 3 over there. If anything wrong over here, you can just print it out. Anyways, here it would become 3 has to be put it over here. 3 has to be put it over here. So here the result becomes, tell me what's going to be the answer. Tell me what's going to be the answer. Is that part clear? So once you will add them together, lambda 1 dash, lambda 2 dash, and even you can get the lambda 3 dash, that would be equals to of the trace of the new matrix for which they have been the eigenvalues. I can call it trace of the new matrix B, and once you will add them together, the result is simply going to be minus 6. Simply going to be minus 6. Is that part clear to all of us? Is that part clear to all of us? So now you can understand in this way. If instead the a cube minus of 3a square, if it could have been like a cube minus of 3a square plus 6 of a, then end of the day what you had to do, instead the a you can feed lambda. Instead the a you can feed the lambda. Yes? Is there any mistake over here? Anyways, you can see over there the answer we have been finding as minus 6. The answer is minus 6. Maybe somewhere mistake I could have been managed. Is that part clear? Just a minute. Here it is 3, no? Yes, that is what I am saying, no? Here it is 3. That's the mistake I am having. Here it's 3. Yes. Here it's 3. That is what the mistake was happening. Now you can start feeding the data. Here it would be 1 minus 3, that would be minus 4, obviously, that's a minus 4. And then let me write minus 1. So it would become, okay, let me do that. So here basic change has to come. See, the first change, 1 would come over here, it would become 1 minus of 3, that would become minus 2, it would become minus 4, and here it would become 0. And end of the day, the result is going to be minus 6. Till this point, each and everything is clear? Till this point, each and everything is clear or not? Obviously, yes. Obviously, yes. Let me take a problem, and I know that after taking this problem, you guys would be able to appreciate the concept of eigenvalues in the better way. Yes. The problem is I have got a square matrix. Let's take A, which is in order of 2, 4, 0, 3. 2, 4, 0, 3. Yes. You need to get the eigenvalues corresponding to this square matrix, and the eigenvalue is already been calculated. If you want, you can calculate by yourself. The value was found somewhere 2 and 3. 2 and 3. 2 and 3. Yes. Now I wanted to ask one thing. If I design a new matrix A square, what would be the change over the eigenvalues as well as eigenvectors? So far, just understand this. So far you have calculated eigenvalue. Do one thing, taking the reference of lambda is equals to of 2, also try to get the eigenvector. Try to get the value of eigenvector. Yes. May I know what would be the eigenvector? The eigenvector would be 2 minus of 2, that is a 0, 4, 0, and here 3 minus of 2, that's a 1, x1, x2, 0 and 0, 0 and 0. Once will take the result out of this. So simply it becomes 0 times of x1 plus of x2 is equals to 0. That means x1 can be arbitrarily anything, whereas x2, yes or no, x2 would always be 0. x2 would always be 0. If you want, we can write its eigenvector. The eigenvector is gonna be 0. You can write 1 over here. Here it's a k. Here it's a k. Is that part clear? Just try to understand what I wanted to communicate over here, because this concept is unfolding so many doubts you guys are having. See what I have said. In case of A, you had the eigenvalues. If you want, you can calculate it. You had the eigenvalue lambda is equals to 2. Even you can cross check. The addition between their lambdas would be equals to of the trace of the matrix. It's there. 2 plus 3, that's a 5. Even the multiplication between their lambdas would be equals to of the determinant of the matrix. That is also there. That means 2 and 3 is the genuine eigenvalues for the given matrix. Now let me calculate the value of eigenvector corresponding to the lambda is equals to 2. So what I'll do, I'll just feed a minus of lambda I. I'll multiply with x and we'll compare with 0. And end of the day, the result which we got it, see, x2 is equals to 0, that means x2 is going to be 0, whereas x1 could be any real value, Yes. Now, next important thing, you guys had to get the a square. Yes. May I know what would be the a square? 2403 has to get multiplied with the 2403 again. 2403 again. And a new matrix would be formed. 2, 4, 0 and 3 again. May I know the new matrix? The new matrix is simply gonna be 2 2 ja 4, 4 into 0, that's 0. If any mistake happens, you can just put it over the comment box. Similarly, 2 4 ja, that's 8, and 4 3 ja, that's 12, 20 it becomes. I repeat, 2 4 ja 8 and 20 it becomes. Obviously here 0 into 2, that's a 0, 3 into 0, that becomes 0 again, and now here it becomes 0 into 4, that's a 0, and here it's a 9. Now it's your responsibility to calculate its lambda. You can do it by your own. Otherwise, simply I am using the formula, or simply I am using the properties which we have used so far. Is that part clear? So here the 2 2 ja becomes 4 and 3 square becomes 9. 3 square becomes 9. Yes. Now. For lambda is equals to a 4. May I know what's the eigenvector? You will feed a minus of lambda I. That's a different thing. Instead the a, now we have got a square, or we have got a new matrix at all. So 4 gets subtracted with the 4, it will become 0. 20 minus of 4, that would become 16. Here it is a 0. 9 minus of 4, that's a 5. Let's take, you have got a new eigenvectors again. The values are x1 and x2 is equals to of 0 and 0. May I know what's the eigenvector you have got it? You have got it the same eigenvector which is yes, that's it. That is what I wanted to communicate to you guys. Although eigenvalue got changed from 2 to 4, corresponding to 2 I calculated the eigenvector. I got the eigenvector as a k10 corresponding to the lambda is equals to 4. When I got the value of eigenvector, we got the value as k10. As such, there is no change. Is that part clear? Is that part clear to all of us? Because the questions are keep coming from this domain. Is that part clear? If it is clear, just write clear over here. And then we shall move forward. If it is clear, just write clear over the comment box, and then we shall move forward. Tell me. Clear, clear, clear. Okay, let me go ahead with the next question. This is the third question. The problem have come in GATE Electrical, year of 2016. The problem was framed by IISc Bangalore. The problem is based on the same concept. Same concept. Tell me what would be the answer for this. What would be the answer for this? What would be the answer for this? Tell me what would be the answer for this. Initially, you had a 2 cross 2 matrix. For the time being, the matrix has been set as A. You have got the two number of eigenvalues. Already I have seen, if you have a matrix with the order of 2 cross 2, the two number of eigenvalues you'll have. That's 1 and minus 2 for the time being. And thereafter, the eigenvectors corresponding to 1, that's the x1, corresponding to minus 2, that's the x2 respectively. Then eigenvalues and the eigenvectors of a new matrix. Now. The new matrix has been framed as the A square minus of 3A plus of 4I. May I know what would be the new values of lambdas and what would be the new values of their corresponding eigenvectors? Like initially you have eigenvector corresponding to 1. Now also after taking A square it will become 1 minus of 3 plus of 4. New eigenvector, what would be corresponding eigenvector for that new eigenvalue? So just I wanted to have the input from you guys. So the answer have started coming. Maurya Vikas, option A sir, option A sir, option A sir. That's it. That's it. No change in x. They will remain as it is. And yes, the new matrix, let's call it B. What would be its lambda? The lambda can be related with the earlier lambda, which would be lambda square minus of 3 of lambda plus of simply 4. So you have got the two different kinds of lambda. First you will keep lambda is equals to 1 and second you will keep lambda is equals to minus 2. Once you will keep lambda is equals to of 1, it would become 1 minus of 3 plus of 4. 1 and you will get the answer. You will get the answer. Is that part clear? So here it becomes 1 minus 3 of 4, which would become 2, and similarly once you will keep lambda is equals to of minus 2, you will be getting the answer as 14. And keep in mind, corresponding to the lambda is equals to 1 and corresponding to the lambda is equals to 14, the new eigenvector would be very same as the earlier eigenvector. Just try to understand in this way. That means once you have matrix A and you had the matrix A square minus of 3A plus of 4I, you had the lambda over here. The lambda maybe was 1, here also lambda 1 would be how much? Instead the 1 it became 2. Here the lambda was equals to of how much it was? Minus 2. Here it became 14. Now with corresponding to the lambda 1 you had the eigenvector x1, corresponding to the lambda 2 you had the eigenvector x2, but here the same eigenvector got repeated for having lambda is equals to of 2 and 14. Is that part clear? And 14. So the concept is clear till this point. If it is clear, just write clear. Just write clear. If it is clear, just write clear and we'll move forward. So that means as such there is no change in eigenvectors, only eigenvalues are supposed to change. Only eigenvalues are supposed to change. So now you can discuss about the new type of questions have been framed. The problem have come in mechanical engineering. For the matrix A 5 3 1 3, obviously it's a matrix with the order of 2 cross 2. One of the normalized eigenvector is given by. Now, what does it mean by the normalization? What does it mean by the normalization? Understand in this way. We call it unit vector. Could you figure it out? What was the unit vector? If you have a vector like, you can say 2ax cap plus 4ay cap. What used to be the unit vector of this? The unit vector used to be, you will have 2ax cap plus 4ay cap as it is, and at denominator you will just divide it with its magnitude, which is a 2 to the power of 2, that's a 4 plus 4 to the power of 2, that's a 16, and which used to be the unit vector of this given vector. The same concept is already or also applicable over the eigenvector. See, if you have an eigenvector, have the two datas like x1 and x2, maybe they are the eigenvectors corresponding to the lambda 1. If we talk about the normalized eigenvector, corresponding to the lambda 1, what we do? Their magnitude would be taken out and would be divided at outside. It would become x1 square plus of x2 square, and it's simply going to be x1 and x2. So either you can say it's a unit vector of a given vector, either you can say it's a normalized eigenvector out of this vector. Is the part clear? So what you guys had to do with this point or this word, I know it would be a problem for most of us. You need not to worry about it. Just go through a common process, get the lambda. In respect to the lambda, get the value of eigenvector, and whatever the eigenvector you get, you just divide with its magnitude. So the fourth problem is also done. You can do it by your own. Now the question number 5 is based on the concept of Cayley-Hamilton. You can just put it over the heading as a Cayley-Hamilton. And Cayley-Hamilton is nothing great or nothing new. Just I wanted to ask one thing. One thing is what? Let's take, you have a naught lambda to the power of n. Next is gonna be a1 lambda to the power of n minus 1. Maybe a n, or you can just reverse it, that would be even better. You can take in this way. Yes, you take a2 lambda to the power of 2 plus of a1 lambda to the power of 1 plus of a0 lambda. Yes, may I know what would be the result out of this? See, if x is getting multiplied towards both of the side, now this x becomes a2 lambda square of x plus a1 lambda times of x plus a naught times of x. Obviously, what is the x over there? It's the eigenvector. And one more important thing, the lambda square of x can be written as a square of x. What's the a over there? The a is a matrix for which the lambdas are their eigenvalues. So may I know at right hand side what we can write? It's a a2, and here it becomes a square. Keep in mind, it's a square of a number, whereas it's a square of a matrix. Plus of it would become a1 of a plus of a naught of i. And if we compare both of them, what's the result we got it? The simply a2 lambda square a1 lambda plus of a naught became a2 a square plus a1 a plus of a naught i. So either you want to have this thing in your mind or not. You can do only one thing. You can do only one thing. For the time being, you just rub it out this. You just rub it out this. But you should have a clear-cut idea about it. The Cayley-Hamilton is derived from the concept of eigenvalues as well as eigenvectors. Eigenvalues as well as eigenvectors. You can just write a statement. You can just write the statement. Just write the statement. Any square matrix, any square matrix, any square matrix, satisfies its characteristic equation, its characteristic equation. Any square matrix satisfies its characteristic equation always, always. Satisfies the characteristic equation always, always. Like for any matrix, let's take, you have got a matrix with the order of 2 cross 2, 2 cross 2. For that, the characteristic equation was found somewhere like a2 lambda square plus of a1 lambda plus of a naught is equals to 0. So from this statement, this is nothing but my characteristic equation. Even the square matrix for which this characteristic equation has been written, that square matrix is going to satisfy this requirement, and hence you can say it's a a2, rather the square of a certain number, it's a square of the complete matrix itself, is going to be a1, lambda would become again a matrix A, and keep in mind the a naught has to get multiplied with the matrix. No, here we are playing with the number, but whereas here we are playing with a complete matrix, and would become a null matrix, null matrix. So I repeat what I wanted to say. Any square matrix satisfies its own characteristic equation. Let's take, if you have a square matrix, maybe order of 2 cross 2. So may I know whatever the equation you will have, will it be a quadratic equation or will it be a cubic equation? That solely depends the order of the square matrix. If it is a 2 cross 2, obviously it's going to be a quadratic equation. Now instead the lambda, if you are feeding A, although you might be looking, sir, everything is fine, it can be done, but it is a very important conclusion what the Cayley-Hamilton has been brought it out. Here it was playing with the number, but whereas here we are playing with the matrix. But anyways, as we have talked about the concept of eigenvalues and eigenvectors, they had to get satisfied. They had to get satisfied. Is that part clear? So now the next thing comes in mind. So what's the advantage of it? What's the advantage of it? Yes, we have lot of advantages for it. We have lot of advantages for it. If you want, by taking this numerical, I am going to unfold what are the different advantages we can get once we have this equation. Once we have this equation, or the equation where the lambda has been interchanged with its square matrix. Have you written till this point? Because I am going to just rub it out and I will take the reference of this equation and we'll move forward. I repeat, have you written till this point? Because I will just rub it out and I will take the reference of this equation to just understand of the concept of Cayley-Hamilton. I want the reply over the comment box. If you guys have not wrote so far, you can just write it out in a faster way, Noted, sir, no? Okay. So let me do one thing. Let me rub it out, come back. Now what is happening over here? First focus over the matrix and try to get the characteristic equation for the given matrix. How do we get them? It's a simply mod of A minus of lambda I, which becomes minus of 5 minus of lambda minus of 3, 2 minus of lambda, and once you had to compare with 0. Is that part clear? So what I'll do now, I'll just multiply. So here it will become 5 of lambda plus of lambda square, and here it becomes 6 is equals to 0. Obviously, yes. So this is nothing but my characteristic equation. This is nothing but my characteristic equation. But as per the Cayley-Hamilton, even the square matrix, the same square matrix for which this is the characteristic equation, is going to satisfy this equation. So straight away, without thinking much, lambda would be replaced with a. So it would become a square plus of 5 of a. Keep in mind, it became a square matrix, no? A square would be a square matrix of a 2 cross 2, 5 of a would be a square matrix of a 2 cross 2, and hence the 6 should also be a square matrix of 2 cross 2. So here it would become 6, it would get multiplied with a identity matrix with the order of 2 cross 2. With the order of 2 cross 2. Is that part clear? Now, what's the advantage, as I have said, can get out of this? See. Easily you can get the value of a square. What would be the a square? A square is simply equals to of minus 5 times of a minus 6 times of I. That's it. You know the value of a, you feed over here. You know the value of minus 6 times of I is going to be 1001. Straight away the a square got changed into the linear form of the matrix. That means the a square could got calculated in terms of a. Even you wants to go into the higher degree, like you are interested in calculation of a cube. What you can do now, in first equation you can multiply a, so it would become a into a square would become a cube, and now it would become minus 5 times of a square. May I know what's the a square? A square is again known to me, which is equals to of minus times of 5a minus 6 times of I. Is that part clear? And end of the day is going to be minus 6 times of I, and I gets multiplied with a, it's again a. So what's the result we are getting? Although you may have a to the power of 10, 20, 30, but all of the raised to a certain higher power would always be compensated in a form of a linear fashion. You can see it's a linear fashion. So if you want, you can write it over here. A cube is equals to of minus 5 and minus 5, that would become 25. 25 minus of 9, that's going to be a 16 of a, and here it becomes 30 of I. Yes. You want, you can straight away get the value of this. Not only that, by just feeding the value of a, you would straight away get the value of a cube. So far we saw the a square, a cube got calculated. Even with the help of the same concept, you can calculate the value of a inverse also. I'll just give an example. Multiply a inverse both other side. So what will become a inverse into a square would become a. 5 into a inverse into a would become 5 of I, and here it's simply going to be 6 times of a inverse. So here it would become a plus it would become 5 times of I, and here it would become 6 times of a inverse 0. So easily you would be able to get the value of a inverse, and which is equals to of 1 upon 6 with a minus sign, a plus 5i. So as far as this topic is concerned, the questions are rarely asked, but still you should have a little bit idea what is the Cayley-Hamilton stands for. The Cayley-Hamilton is just a understanding between the characteristic equation and the actual or the father matrix, that the father matrix will always satisfy its characteristic equation. Is that part clear? So probably till this point each and everything is clear to all of us. Now let me go ahead with one of the very important topic, and that's gonna be the solution of the linear equation. The heading as solution of the linear equation, and the problem do come repeatedly from this particular topic, solution of linear equation. So let me make a certain flow chart. So once you have flow chart in your brain, probably you will not going to stuck anywhere. See, first of all, the linear equation would be bifurcated into the two parts. The linear equation would be bifurcated into the two parts. The first is going to be linear homogeneous and the second is going to be linear non-homogeneous. The first kind is going to be linear homogeneous and the second kind is going to be linear non-homogeneous. Linear non-homogeneous. Yes, but how would you recognize the problem through which you are playing with or the problem which you are going to deal with, whether would fall under the homogeneous form or the non-homogeneous form? See, the homogeneous form would be having the structure like AX is equals to a null matrix, whereas non-homogeneous would have the structure like AX is equals to B, where the B is not a null matrix, where B is not a null matrix. B is not a null matrix. By taking an example, at least we can visualize in the better way. So, just a minute, yes, we can visualize in the better way. Let me take one example. Like example is 2x plus of 3y is equals to 0, 3x plus of 4y is equals to 0. Easily you can write this linear equation in this format, where the format would become, here it would become 2, 3, 3, 4, 3, 4. Here the column matrix capital X would have the two values x and y. Towards right hand side, all of the datas are 0. So definitely you can say it's a form of linear homogeneous equation. Similarly, you can have another problem over here. The problem could be like 2x plus 3y minus of 6 is equals to 0, 3x plus of 4 of y is equals to 0. It's a perfect example of a linear non-homogeneous equation. Why? 2x plus 3y would be kept towards left hand side, whereas minus 6 would be shifted towards right hand side. And end of the day, if you really wants to fabricate the matrix out of this linear equation, you will get to know your matrix is going to be 2, 3, 3, 4, which is getting multiplied with the x and y. 6 and 0. Yes. So just by seeing this, you would be able to know many of the things. It's a null column matrix, or for the time being you can just write null matrix. And similarly, it's a non-zero column matrix. Yes. Let me go down. Now, again come back. In case of linear homogeneous equation, how many solutions you can have? I just ask from each one of you, in case of linear homogeneous equation, how many equations or how many type of solutions you can have? How many types of solution you can have? Can you have the case of no solution in case of linear homogeneous equation? Just I wanted to ask one thing. You had to reply over the comment box. Can you have the case of no solution in case of homogeneous equation? Yes or no? Yes or no? Can you have the case of no solution in case of homogeneous equation? Tell me. I want the reply from each one of you. Can you have the case of no solution, unique or infinite solution? 3 types. I am just specifically talking about the homogeneous equation. No. Why no? Just understand in this way. Just understand in this way. Could you figure it out or not? See. If right hand side have value as 0 alone, that means at least x is equals to 0 and y is equals to 0 is going to satisfy your requirement always. If you keep x is equals to 0, y is equals to 0, x is equals to 0, y is equals to 0, left hand side, right hand side, left hand side and right hand side will always get matched. What does it mean of it? If you are playing with a homogeneous linear equation, 0, 0 would always be a solution. Like if the number of unknowns are 2, the x is equals to 0 and y is equals to 0 would always be a solution. If the number of variables are 3, like you have got x as well as y as well as z, in that case the x is equals to 0, y is equals to 0 and z is equals to 0 would always be a solution. But the next thing, whether 0, 0 or 0, 0, 0 is the only solution, now that we have to see now. That means you will never have a situation when you are not getting any solution for this equation. Always you will have one solution as 0, 0. Always you will have one solution as 0, 0. 0, 0. Even you can understand in this way. Let me draw a plane. Let me draw a plane. May I know what it would be? It's a straight line. Crossing through, C is kept 0. What does it mean of it? Crossing through origin. So how many number of situations you can have? Just try to understand. See, let's take, this is what my first equation, which is crossing through the origin, and let's take, this is what my second equation, which is again crossing through the origin. And 0, 0 would always be a solution. There is no doubt in it, because both of these straight line has to cross through the origin. So may I know what would be the nature of the solution? It would have a unique solution. Whenever the homogeneous linear equation has the unique solution, keep in mind that solution would always be 0, 0. Maybe in case of 3D coordinate 0, 0, 0, or in general trivial solution. Is that part clear? So here it's a case of unique solution or trivial solution. Is that part clear? But you take another scenario. Rather having a two informative equations, if you have only one informative equation, like the first one is 2x plus 3y is equals to 0 and the second one is like 4x plus 6y is equals to 0. How many number of equations you have, boss? I repeat, instead the 2x plus 3y is equals to 0, now the second equation is like 4x plus 6y is equals to 0. How many number of effective equations you have? Only one, because the second equation is linearly dependent on the first equation. And if 2x plus 3y is equals to 0 is alone a equation, how many number of solutions you will have? That means you have only one equation. And if you have only one equation, you will have infinitely many solutions, including 0, 0. That means always you are going to have a solution as 0, 0. You can have the different scenario where the 0, 0 itself is a solution, or it's only one solution, or infinitely many solutions where there are so many solutions including 0, 0. Is that part clear? So let me go down. The first important point. There would always be a solution. That means linear homogeneous equation is always a consistent equation. What does it mean by the consistent equation? The equation which should possess the solution. I do not worry whether it's a one solution, two solution, three solution, four solution, or infinitely many number of solution. If you want, you can write somewhere. So the equations are said to be a consistent equations if they consist at least one solution. So for one of the very important point regarding this, it would always be a consistent. And even the consistency consistency, you'll have the two different characters. You'll have the two different characters. May I know what are those characters? Either you'll have a unique solution, and once you have a unique solution, by default that would be a trivial solution. In case of 2 variable, that's going to be 0, 0, and in case of 3 variable, it's going to be 0, 0, 0. Or either you'll have an infinitely many solution. You'll have infinite many solution, and even the infinitely many solution would also possess the solution 0, 0, maybe 0, 0, 0. Is that part clear? Unique solution and infinite solution. Unique solution and infinite solution. May I know when you'll have a unique solution and when you'll have an infinite solution? See, if the number of informative equations are very same as the number of independent variable or number of variables, then you'll have a unique solution. May I know what it is? It's a 0, 0. Maybe 0, 0, 0. In case of 4 variable, it's 0, 0, 0, 0. And may I know when you'll have an infinitely many solution? If the number of variables are more and the number of effective equations are lesser. Straight away, we are going to use the mathematics. What I will do, I will just calculate the rank of the matrix A. The rank of the matrix A would tell you the number of effective or number of linearly independent equations. If the number of linearly independent equations are very same as n, may I know what's the n over here? Nobody should confuse with the n. N is not the order of the matrix. N is nothing but the number of variables. Number of variables. Similarly, if rank of a certain matrix found lesser than n, what does it mean of it? What does the mean of it? That means the number of effective or informative equations are lesser than the variables. So end of the day, you'll have an infinitely many solution. So one of the best thing regarding the homogeneous equation, out of 4 number of equations or out of 4 number of options in MCQs, only 2 options can be fabricated. Either you'll have a unique solution, either you'll have an infinitely many solutions. Now in case of MCQs, what they do, they will write infinitely many solution, they will write unique solution, they will write 2 solution, they will write 3 solution. 2 and 3 cannot be the answer at all. Either you'll have unique 1 solution or either you'll have infinitely many solution. Could you understand what I am saying? Like in this case, they have been 2 different straight line, or I can say their equations are linearly independent, and from where they have been crossed through, the origin or the trivial point. Now instead this equation, if 2x plus 3y is equals to 0, and the second equation would have been dependent on 2x plus 3y is equals to 0, so what you can say, sir, I have got one equation and even the second equation is overlapping over the same equation. So if you talk about the point where both of the equation of line or both of the linear equations are getting satisfied, you will get all of the points which are lying over this straight line, including origin. So what would be your mathematical approach? Whenever you are dealing with the homogeneous equation, just focus over the rank of the matrix A. If the rank of the matrix A is precisely equals to of the number of variables, then you'll have a unique solution. May I know what would be the unique solution? That would be trivial, 0, 0, 0, 0, 0, 0, 0, 0, depending on the number of variables. And similarly here, if rank of A is lesser than n, then you'll have infinitely many solution, but that solution will also contain 0, 0, or in short, trivial solution. Agreed? Till this point, each and everything is clear? No. But the case is bit different. In case of non-homogeneous. You can have varieties of the solution. Let me mark all of them. You can have varieties of solution. You can mark all of them. No solution. When you will have no solution, just try to understand. When you will have no solution, let's take it's my first equation, which is a linear equation, and it's my second equation. Both are parallel to each other. That means they are not going to intersect anywhere. And if they are not going to intersect anywhere, that means you will not have any point where both of the equations, that's the first equation and the second equations, are satisfying each other, and it's a case of no solution. It's a case of no solution. No solution. Yes. When you'll have a case of unique solution, see, if you have got a situation when both of these straight line have got the different slope, and if both of these straight lines have got the different slope, that is for sure they had to meet at somewhere, and wherever the point they get met, by default that is gonna be the only solution of this linear equation, and you'll have a unique solution. Unique solution. And may I know how the infinitely many solutions you'll have? The same scenario. Let's take the first equation is this, and even the second equation is also linearly dependent on the first equation, or you can say the first and second equations are very same, or you can say they are just overlapping on each other. So may I know how many number of solutions you'll have? All of these points would come under the solution of the equation, and you'll have infinitely many solution. You'll have infinitely many solution. Yes. Unique solution and infinite solution comes under the consistent. That means the equations are consistent. Or if you have got a case where no solution is found, it's called non-consistent. Is that part clear? So let me know how the consistency and non-consistency would be judged mathematically. See, here we have got plenty amount of depth with this particular concept. Even I can discuss next 1.5 hours just based on this concept, but as far as the crash course is concerned, we need not to go into that detail. Trivial solution. Is that part clear? Now, so what we do, first we get the rank of A and we compare with the rank of A augmented B. Rank of A augmented B, we'll see how we do that. If it is not same, the problem will fall under the non-consistent or inconsistent. Similarly, now if you have calculated the rank of matrix A and if the rank of A augmented B matrix have the same rank, the problem will fall under the consistent solution. Now you can go ahead with the two different possibilities. Either the rank of A is equals to of rank of A augmented B is equals to of n. I repeat, n is nothing but the number of variables. Then you have unique solution case. And similarly, if the rank of A is very same as the rank of A augmented B, but the rank together is lesser than the number of variables, then you'll have an infinitely many solution. Yes. So just tell me, could you write this thing? You guys, could you write this thing? Probably you guys are well aware with this concept, but still I am not going into the great detail because so many details are still left out with the trivial solution, unique solution, infinitely many solution, but it's not required, at least in case of crash course. Have you written this? One question have been asked somewhere, the trivial solution is not possible. Obviously, trivial solution is not possible in case of non-homogeneous because they will not meet or they will not cross through the origin or the point where the x, y or maybe in future x, y, z all are 0. Yes sir, noted. So let me go ahead with the question. Let me go ahead with the question. Tell me what's going to be the best most answer for this. What's going to be the best most answer for this? What's going to be the best most answer for this? I want the reply from each one of you. I want the reply from each one of you. What's going to be the best most answer? Tell me. One of the best thing, first focus over the pattern of the linear equation. It's a linear homogeneous equation. So how many type of solutions you can have? Either you have unique solution as a trivial solution or infinitely many solution. So no solution is knocked off. Non-zero unique solution is also knocked off. If you have a unique solution, that would be 0 and 0. That would be 0 and 0. Is that part clear? That's the best thing regarding a homogeneous equation. Out of 4 number of options, definitely 2 options would never be true. So just by seeing the problem itself, you can eliminate the 2 options, because you will have either unique solution as trivial solution or infinitely many solution. Now, you just had to focus whether you have got how many number of informative equations. You can see very well the first row and second row are the linearly dependent row. What does it mean of it? Although you may write, you have equations as, but by just saying that we have got the 2 number of equations, it is not like you have got the 2 equations. In that way, you can write the infinite number of equations. How? See. 2 got multiplied, you made another equation. 3 can be multiplied, you can make another equation. 4 can be multiplied with this, you can make another equation. Is that all of them are informative equations? No, not at all. Not at all. Is that part clear? So what does it mean of it? This is just linearly dependent on the first equation. If I would say what would be the answer is simply gonna be 2 and 2 is getting cancelled out. x1 is equals to of x2. May I know what are the solutions you can have? You can just select the value of x. The x2 has to be very same, like 1 1, 2 2, even 0 0. They all are the possible solutions. So how many number of solutions you have? Infinitely many solution. That means in future you can select any real number k that gets multiplied with 1 as well as 1. The values would be that. Hi sir. Okay, Pawan, hi. Anyways, just focus on this. Now let me go down to the next. Deliberately, the next question which I have chosen, this problem is the problem from where? In homogeneous equation. Why? Because you can see very well it's a 1 minus 2 3, 1 minus 3 4, minus 2 4, minus 6, x y z, and here the column matrix what we have, it's a non-zero matrix. Tell me what's going to be the answer for this. What's going to be the answer for this? Either you can use the concept of rank of A augmented B, or straight away you can use something else. Try to understand this way. See, the first equation and the third equation are going to be linearly dependent if little bit articulation is made. Moreover, it has been clearly given we need to get the value of k when we have an infinitely many solution. Number of effective equations, either you can go straight away using rank, or you can take the basic concept number of effective equations must be lesser than the number of variables. How many number of variables you have? 3 number of variables, and the first equation and third equations are almost sort of dependent equation. How? If minus 2 is multiplied in equation number 1, so it would become minus of 2x plus of 4y minus of 6z. Now what happens? if -1 is multiplied with the -2, if the same value comes in place of k, what will happen? Equation number 1 and equation number 3 would be completely linearly dependent, and the number of effective equations would be 2, whereas the number of variables are 3. So what you had to do? Just you had to make sure the R3 is equals to of -2 times of R1. Towards the left hand side, obviously they are very same. Just you had to mark this out towards the right hand side also. R3, may I know what it is? It's a k -2 times of -1. Result is simply gonna be 2. Result is simply gonna be 2. You'll have infinitely many solution. You'll have infinitely many solution, and that's what the answer is. That's what the answer is. Is that part clear? May I know if k is not equals to 2? If k is not equals to 2, what would be the solution? What would be the solution? In case of k is equals to 2, you have got the infinitely many solution. But deliberately, if you have kept k is not equals to 2, which type of solution you'll have? Which type of solution you'll have? I want the input from each one of you. What would be the type of solution you'll have? Tell me, which type of solution you guys will have? Tell me. Inconsistent, no solution. Why? Why no solution? Try to understand in this way. See here, if -2 is multiplied towards the left hand side, it became -2x, it became +4, it became -6. So the right hand side should become +2, no? Yes or no? Obviously yes, yeah. If the left hand side is multiplied with the -2, the right hand side should get multiplied with the -2. If it is not happening, that means either this equation is true or this equation is true. Both of them cannot be true at any point. Could you understand? See, if you are saying, sir, x is equals to of y, so in future you would say that no, that -2x would also be equals to of minus of 2y. If first equation is true, the second can't be true if k is not equals to 2, and similarly if third is true, the first cannot be true. That means at any moment of point, the equation 1 and equation 3 cannot be same together, and hence you'll have no solution case. No solution case. Is that part clear? Not unique solution. In k is equals to of 2, you'll have infinitely many solution, and in case of k not equals to 2, you'll have no solution. If you want, you can just check it out. You can keep k is equals to 3. Now at your turn, you need to get the rank of A and you need to get the rank of A and B together. What does it mean by the A augmented B? That means you will take all of the elements of the matrix A and thereafter you will introduce another column which is coming from matrix B. Yes. So rank of this, you can say rank of this, it's gonna be 1 minus 2 3 1 minus 3 4 minus 2 4 minus 6. You need to get the rank of this matrix. Once you'll get the rank would be 2. Rank would be 2. And similarly, A augmented B, 1 minus 2 3 1 minus 3 4 minus 2 4 and minus 6, and the B has to come over here. Let's take it's a minus 1 1, and the K has been taken any value which is not equals to 2. Let's take it's 3. And once you'll take its rank, you'll get to know the rank is found to be 3. Rank is found to be 3. And when the rank of A and the rank of A augmented B is not same, the result would be inconsistent and no solution would be there. Now this problem has to get solved by you guys. You can take the screenshot or you can write over this. Is that part clear? So okay dear friends, from tomorrow onwards we'll start a new topic within the engineering mathematics, and we'll have a new understanding of the engineering mathematics from tomorrow onwards. So end of the day, I would say only one thing: focus over the study. And if you guys are finding little bit difficulty anywhere, you can just put or you can just drop the comment over the Telegram group of mine. There I will try to discuss any sort of doubts if you guys are having. Is that part clear? So till then, bye bye, take care.